Good morning, everyone. My name is Kira Proctor, and welcome to our 11th webinar of the year. Our series of webinars have been running now since 2020, and if you've missed any, you can go back and review them all right here on our YouTube channel. You can also catch up on our Learning Hub at www.proctorgroup.com, where you can book in for follow-ups with our team of experts around the country, access up-to-date information on our full range of products, or order product samples. Today we have a special guest presentation from Richard Crossley, the Technical Director of Newton Waterproofing, who will be discussing the design principles involved in integrating waterproofing and gas protection measures. As usual, we'll follow up with a Q&A, where Richard will be joining our team of technical experts to answer your questions. So I'll now pass over to Richard to begin today's webinar.
Hello, my name is Richard Crossley. I'm Technical Director for Newton Waterproofing Systems. I am a CSSW, that's a Certificated Surveyor in Structural Waterproofing, and also a Registered Waterproofing Design Specialist. Welcome to our CPD on creating a barrier to gas and water, where we convey how to correlate the different standards within waterproofing and gasproofing industries. The aim of the presentation today is to provide a technical overview of the requirements of the codes of practice and the British standards that cover both water and gas. We will discuss a design philosophy whereby we choose a waterproofing systems appropriate for the grades of protection, then upgrade these to form a dual purpose, thus including gas protection. With gas, as I'm sure many of you will be aware, these are the predominant standards. They are mostly concerned with ground level damp proofing, as you will see from the covers, using a polyethylene damp proof membrane. They do in a small part cover basements or below ground structures, as we will see. With gas proofing above ground, the solution is generally to mitigate quantity by removing and or cleaning, then ventilating. Then a barrier is created to resist the remaining gases. This relies on clear paths for ventilation, quality assurance and 100% perfect installations. But below ground things are different. External ground levels that are higher than the internal floor levels are a route or conduit for water to be delivered against a structure, and it doesn't matter if there is 10 centimetres or 10 metres. The result can be the same, i.e. water ingress that can affect the internal space. If we can remove or design out the high external ground levels, then we have removed the risk of water ingress, but if we can't, we are obliged to consider waterproofing measures. When looking at waterproofing solutions, there are three defining factors that take us down the path of providing an effective and robust solution. Chiefly, we keep the pertinent reference documents at the forefront of our minds. Then we look at the type of structure proposed to be built and the requirements and expectations for the internal environment. The BS 8102/2022 is the code of practice for the protection of below ground structures against water ingress. It's the predominant document for design of basement waterproofing. The British standard gives recommendations and provides guidance of methods of dealing with and preventing the entry of water from surrounding ground into a structure below ground level. It isn't the only reference document available, but it is the one which expert witnesses in cases of litigation or dispute use very effectively to analyse design. Though BS 8102/2022 is not law, it has been used successfully to break down a design in a court of law. With regards to building regulations, the latest edition of the HM Government Building Regs Part C is a 2004 edition with amendments made in 2010 and 2013. However, it still references the 1990 version of BS 8102, despite there being a new 2022 version. It's also often useful to know if the project insurer has any relevant guidance literature outlining their interpretation of the standards. Here we can see NHBC and MD Insurance's technical manuals for LABC and Premier guarantees. A significant factor in the recommendations of BS 8102/2022 is the inclusion of a waterproofing specialist within the design team, a recommendation which is also supported within the insurer's guidance documents. The inclusion of a waterproofing specialist is recognised to offer the best chance of success. Specialists should be certificated surveyors in structural waterproofing, CSSW, or registered waterproofing design specialists, WDS. If the rebus stages are used, a waterproofing specialist needs to be appointed before the technical design stage at the latest, at stage 4. BS 8102/2022 recommends that a site investigation is undertaken to assess the height of the local water table, both current and historic. However, this is only a snapshot in time, and whilst the information from a study may be useful with regards to ground gas and contamination, The water table can vary over time, influenced by a number of potential factors. There are perched water tables and the effects of defactorization and deforestation to take into account. Designers need to protect structures from water not only in the ground, but also water introduced into the ground. For example, a burst water main or sewer, or a new adjacent structure diverting water towards the building. In heavy and prolonged rainfall events, water will take time to percolate through. You would be a brave person to bet that water would never come to bear against a structure that is built below ground at some time in its design life. It is widely accepted, therefore, that at some time in the design life of the structure, it is prudent to expect a full head of hydrostatic water pressure to ensure the ultimate success of the proposed waterproofing strategy. The BS includes Table 2, which defines waterproofing protection grades of performance for below ground spaces, achieving the required internal environmental conditions, and has graded them as Grade 1A, seepage and damp areas from internal and external sources are tolerable. Seepage is defined as a slow transmission of water through discrete pathways of a structure. If there is seepage, there is a possibility of mineral deposits such as calcium carbonate, free lime forming. Grade 1B, no seepage, but damp areas from internal and external sources are tolerable. A damp area is defined as an area which is slightly wet but no seepage. Grade 2, no seepage is acceptable. Damp areas only as a result of internal air moisture are tolerable. The difference now between grade 2 and 3 is that ventilation, dehumidification or air conditioning is necessary. The agreed grade should meet with the client's expectations for their intended use of the below ground space. Reducing the grade could increase the risk of not meeting the client's expectations for their intended use of the below ground space. The British Standard gives us 3 systems to achieve the waterproofing protection. Type A, barrier protection, where a fully bonded waterproof membrane is used either internally or externally to create a homogeneous barrier, also known as tanking, because we are forming a tank. Type B, structurally integral protection, whereby the reinforced concrete is designed to BSE in 1992. Where some seepage is tolerable, as in grade 1A, the provisions in tightness class 0 of BSEN 1992 Part 1 may be adopted. Where grade 1B is required, the maximum permissible through crack width of the concrete should conform to BSEN 1992 Part 3, tightness class 1. This is 0.2 mm crack width. Type C, drain protection, quite different to the barrier protection in A and B. The Type C system does not hold water back. It is not a barrier system. It manages and controls seepage through the structure. An ideal waterproofing solution would be defect-free. However, section 4.3.2 states that it should be taken into account that defects might occur in the waterproofing, which then, if subjected to water pressure, could result in the required internal environment not being achieved. These are defects owing to design, poor workmanship, inappropriate use of the materials being used, and defects owing to the specific properties of the materials, as well as defects caused by follow-on trades and site operations. This is supported by case law that rules it is unreasonable and unrealistic to expect 100% perfection in a waterproofing system. Where that system has to act as a barrier to water pressure, we should expect defects. We have briefly discussed the different forms of waterproofing systems available to us. BS 8102 states that waterproofing design specialists should consider a combined waterproofing system approach, where in a single system, the likelihood of leaking is high, or the consequences of failure, and that's failure to achieve the required internal environment, or the consequences of failure is unacceptable. With this in mind, the possible combinations of waterproofing are types A, B, and C, type A and B, type A and C, type B and C, or type A and A, external and internal. Usually a combination of 2 forms of waterproofing is adequate when designing a habitable space requiring a completely dry internal environment. But the BS 8102/2022 also states in section 6 that consideration should also be given to the particular combination chosen, and that they should have different performance characteristics to mitigate the risk of failure due to a common cause. Therefore, whichever combination of barrier waterproofing is chosen to achieve the grade 3 environment, in most cases the safest combination will include a type C internal drain membrane system to manage seepage from the potential defects. The choice of the barrier system is largely dictated by the type of structure. So adversely to gas proofing, with waterproofing we try to stop the water first, but we have to expect defects, so we then manage the seepage. Gas proofing depressurizes first, then has a barrier. Waterproofing has a barrier first, then depressurizes. Waterproofing systems cannot use external drainage or ventilation membranes in the same way that gas does, because these are likely to fill with water, eliminating any chances of ventilation. Where reinforced concrete is used, this can be the primary barrier. Where composite forms of construction are used, we need to use a type A as a primary barrier. It is worth mentioning that the BS 8102 2022 states that composite and modular forms of construction are inherently high risk. These ought to be avoided. Assessing the gas capabilities of a waterproofing design. British Standard 8485 2015 provides us with all the tools we need in order to accurately assess the gas capabilities of our waterproofing designs, provided that we know the characteristic situation, the CS value of our site. The CS value is a score that ranges from CS1, very low risk, to CS6, such high risk that some sites cannot be built, and will be established during your site investigation. Once you have this value, you can then start using tables 3 and 4 of BS 8485. Table 3 outlines 4 different building types with the identifiers A, B, C, and D, not to be confused with waterproofing systems. Once we have categorized our structure into one of these A, B, C, and D types, we can move on to Table 4. Table 4 cross-references the CS value of the structure with the building type that was established in Table 3 in order to calculate the minimum gas protection score that must be achieved by both the structure and its protective measures. The next table is Table 5 and relates to barrier, or our primary barrier, which is Type B, concrete, and shows that any structural waterproofing design meeting the criteria for an old BS 8102 2009 Grade 3 basement will achieve 2.5 points. In our opinion, and in the opinion of many waterproofing design specialists, this is only achievable if a Type C cavity drain membrane system is included. However, with the title of Table 5 being Gas Protection Scores for a Structural Barrier, the suggestion is that a Grade 3 basement is achievable with just a concrete structure. It is also assumed that the difference between an old Grade 2 and Grade 3 structural barrier is the width of any structural cracks. Therefore, it is essential that the concrete is designed to Part 1 or Part 3, respectively, of British Standard BS-EN 1992. As discussed earlier, the British Standard for Waterproofing, BS 8102, has been updated since the release of BS 8485, and Table 2 of BS 8102, which outlines the grades of performance for below-ground spaces, has also been changed and updated. This has a particular impact on the recommendations contained within Table 5, as BS 8102 2022 now relates Type B barrier protection to Grades 1A and 1B, not 2 and 3, and includes an important differentiation between Grade 1A and Grade 1B, and how this relates to Eurocode 2 for the design of concrete structures. To refresh, where some seepage is tolerable as Grade 1A, the provisions in Tightness Class 0 of BSE in 1992 Part 1 may be adopted. Where Grade 1B is required, the maximum permissible through crack width of the concrete should conform to BSE in 1992 Part 3, Tightness Class 1. This is 0.2 mm crack width for flexural and through section cracking. Where higher waterproofing performance grades are required, additional measures, combined protection, can be used. It also states water resisting admixture. However, very important, in section 9, it states that manufacturers should be consulted as to the performance of a specific water resisting admixture in reducing the risk of water penetration through a crack, possibly under considerable hydrostatic pressure. This is because concrete is already waterproof. It's 2.5 times the density of water. Concrete leaks where the concrete isn't, such as at cracks. If 2 gas points are available from Table 5 for water tightness class 0 for Grade 1A, then there will be seepage. If there is seepage, then there could be dissolved gases within that seepage. So Type B waterproofing is a barrier, and it's there to resist the hydrostatic water pressure, which means that the system has to be 100% defect free. Again, it's difficult not to guarantee this in site conditions, and it's not unusual to find areas of honeycombing as a result of poorly compacted concrete. So again, relying on this form of waterproofing solely where a guaranteed dry internal environment is required, as well as gas proofing, is risky. We cannot form the tank all at once either. So we'll have joints where water bars, water stops, and water plugs provide type B protection. This image shows a kicker joint with construction joint accessories in the form of a metal water bar and injection hose in the center image. The use of an injection hose effectively creates a repairable type B structure in that the hose can be retrospectively injected with polyurethane or even acrylic resins if leaks occur through the joint. BS 8102 states that services should be avoided. If they are unavoidable, then they shall be designed by specialists using specialist components. And here we can see a solution for sealing tie bolt holes, where the reinforced concrete formwork has been tied together, leaving small holes through the structural barrier. Now we'll miss out table 6 for the time being and go to table 7, which shows how we can also attribute 2 points for a membrane. Now this membrane should be sufficiently impervious to methane and carbon dioxide, capable after installation of providing a complete barrier to the entry of the relevant gas, sufficiently durable to remain serviceable for the anticipated life of the building and duration of gas emissions, sufficiently strong to withstand in-service stresses, for example due to ground settlement if placed below a floor slab, sufficiently strong to withstand the installation process and following construction activities until covered, for example penetration from steel fibres in fibre reinforced concrete or penetration of reinforcement ties, tearing due to working above it and dropping tools, for example. And also chemically resistant to degradation by other contaminants that might be present. When used below ground, these membranes also have to be a type A barrier or tanking systems as per section 8 of the BS 8102/2022. The barrier can be applied externally on the positive side or internally on the negative side. As already discussed, type A systems need to be 100% defect free to work effectively if tested by groundwater. In laboratory conditions, these products will work perfectly. However, when it comes to an on-site installation, this is not always possible, as explained by the earlier case law. Due to this, the membranes need to be fully bonded to the structure to eliminate any water that finds ingress at a defect tracking between the structure and the membrane to find further ingress elsewhere in multiple points around the structure. Continuity to DPC level is also critical, and taking into account sequencing on site from groundworks contractors to facade contractors is often overlooked. Here we will need fully bonded membranes that can withstand point loads from the external leaf, and membranes that can be applied to provide a homogeneous coating or tank around changes in level, wall ties and other tricky transitions. These are usually liquid applied membranes. All these products need to be fully bonded to the structure and tested for gas as per the manometric standards for membrane and joints. But even though a joint may be perfect in a lab, in dry conditions, how will it perform when constructed on a site in wet conditions? Here we see a pre-applied membrane. It's an under slab tanking membrane with many discontinuities. Pile heads, whereby the engineer will not allow a sheet membrane to transit through the compression load of the slab and the pile. Top right, we see a thrust prop, which is attached to the secant pile wall at a whaler with ground anchors through to the earth behind the secant piles. At design stage, these temporary works are not defined, and a verification plan might not be able to take into consideration sequence of build and difficulties to maintain the continuous barrier to water and gas. Type A internal systems are liquid applied so that they form a capillary suction bond. Sheet membranes used to be applied here and sandwiched between a further internal construction, but this has been written out of the standard due to historic failures where water would come in through the structure, track at will between the structure and the membrane, and then find the defects and soak into the screeds and internal construction. Leak detection nigh on impossible, and the whole lot would have to be ripped out. So now cementitious renders and flexible slurries, often polymer modified, are used in this instance so that they achieve a full bond to the structure to withstand counter thrust or negative pressure. These slurries can be tested for gases using the manometric standards to achieve 2 points as per table 7. These rigid 2 mm to 6 mm thick renders can withstand, in lab tests, up to 100 meters of water pressure. So it is vitally important that the waterproof specialist discusses the existing structure with the engineer to establish whether this will change the status quo of the structure. If the existing structure is historic, heritage or listed, the Conservation Office needs to be involved at early stages to ensure suitability of the system. And here we can see an example of differential substrates that could cause cracking and debonding and opportunities for discontinuation in the internal tanking. Figure 9 of the BS8102 shows how water can track from a defect, so all waterproofing systems have to prove that they are fully bonded. A pre or post-applied membrane can be considered fully bonded if it prevents lateral migration of water from a defect, as per figure 9, and is deemed fully bonded up to the depth of pressure outlined within the test report. Characteristics of sheet membranes for water tightness of membrane and joints and the lateral water migration can be assessed by their performance to BS-EN 1928 method B. Here we can see an external drainage membrane, which is often used with type A systems, sometimes as protection, but also can be useful on semi-retained structures or on steep hills where groundwater can be safely drained away from the structure in order to eliminate hydrostatic head. These will need to be maintainable and will not be considered suitable for venting, as they could be full of water or blocked with fines. Type C, drain protection. Type C is our fail-safe system, where it is accepted that water could enter the internal space of the building. Type C systems work differently from types A and B in that instead of holding back water pressure, they use strategically placed air voids to depressurize and then manage the water away from the structure. This quite often leads to them being referred to as water management systems. The system depressurizes water and manages any water ingress into the structure via drainage conduits and pumping systems. The drainage conduit is situated at the wall floor junction, the weakest area of the structure. Strategically placed inspection points are included in the design, which conforms to the BS8102 2022 recommendation of a maintainable system. Cavity drain waterproofing systems are the most highly recommended and considered to be the most reliable and risk-free type of waterproofing as a single system and the ultimate contingency plan for internal environments that must be 100% dry. Collecting, moving and discharging ingressing water within a perimeter drainage system, which includes strategically placed inspection ports, means that the cavity drain system becomes fully maintainable as it can be inspected, cleaned and jetted at regular intervals. This maintainability is a key recommendation within Section 10 of the British Standard for Waterproofing. The maintainable drainage medium, the base drain and floor drain, has overcome the historic potential problems with using dimpled sheet systems internally on existing and new build structures. Its simple method of dealing with water at known weaknesses, the wall floor junction or daywork joints, and quickly and effectively moving water to an evacuation point, passive or mechanical, has now been adopted as a norm in using cavity drain membranes. By using base drain, you are dealing with any risk of interstitial condensation forming on the room side of the membrane, dealing with defects in the application of the membrane, plugs or defective jointing, by the water being able to enter the base drain through the condensation strip, dealing with ground gas that could potentially enter the property with sump and control unit forming positive air curtain. And it's important to note here that where we're dealing with ground gases, we must seal the condensation strip and double seal all the joints and plugs, and then the reliance really then is on ventilation and dehumidification in the room to eliminate condensation. Also with the base drain system, we've not got running water across the slab with the risk of calcium carbonate and limescale occurring and blocking the system. The base drain can be sat easily within a cavity, access is still required, or out the front of the blockwork in a skin wall. Curved bends and T-pieces are all a part of the system, making the system maintainable across a multitude of design. Most importantly, designing a maintainable element to the waterproofing system, which cannot be achieved as effectively with any other approach. The most critical element of the cavity drain membrane system is the unhindered removal of water from the system. If water cannot drain to a safe area, meaning lower than the level of the underside of a slab by gravity, then we need to employ mechanical water removal. When using a sump and pump system to conform to the British standard, we need to use 2 pumps and a battery backup system as a standard. We would use a high water level alarm on the duty pump, so that if the duty pump failed, the high water level alarm would be set off, alerting the client to a failure, and then the backup pump would be set a little higher so that would then kick in. The Type C system has been used for many years as a water and gas management system, either a fully sealed, naturally vented and drained system, or as a positive air curtain system that uses sumps and pumps to discharge water and vents from the sump that push the air clear of the basement structure. In section 6.12 of the most recent 2015 edition, BRE 211 recognises that below ground waterproofing and radon management are specialist activities that can conflict. It is recommended that dual protection systems are designed and installed by specialists who are suitably qualified in both waterproofing and radon management. The standard also makes two important points regarding Type C cavity drain systems, namely that cavity drain systems used in scenarios requiring radon management will need to be completely sealed. It says using cavity drain membrane systems to line the internal surfaces of a basement could cause the gas to be simply displaced up the cavity into the ground floor accommodation. It is therefore important to ensure that the basement wall membrane fully closes the cavity at its head where it meets the radon barrier within the ground floor or external cavity wall above ground. And furthermore, that such Type C systems can also provide the opportunity to create ventilation. It states the cavity behind the membrane could be used later as part of a subfloor depressurization system. In these instances, we have successfully achieved points from Table 6 from the BS 8485 by either passive ventilation or by positive air curtain. This is a bolt-on to the Type C system that uses a channel at high level and a fan to pressurize the Type C system that will then exhaust via a vent from the sump. Verification companies can carry out a gas integrity test to the cavity drain membrane installed by the Newton-approved waterproofing contractor. The membrane is to be double sealed by way of tape between the membranes and over tape. The fact that the test is carried out by a third party and not the membrane installer complies with BS 8485 and Syria 735. The tracer gas is introduced to the rear of the membrane via the channel, and the membrane is swept using a specialist detection equipment, paying particular attention to fixings and joints to ensure that the membrane represents a gas-tight barrier. Any defects will be rectified on site at the same time as the test is being carried out by the Newton-approved waterproofing contractor that will be present during the test. Note, the 508 membrane has been tested and certified for radon, methane and carbon dioxide. However, it will not achieve 2 points under Table 7 as a Type A membrane. We can only claim points here for the good ventilation element. Once you've gone to the trouble of ensuring that your waterproofing design and installation is as accurate and professional as possible, it's also worth considering how this will be supported by warranties and guarantees. In our experience, it is important to differentiate between the various kinds of insurance that are presented by suppliers and installers. And this slide provides a brief overview of the 3 levels of cover that can be obtained. Product warranties are statutory. They're available on all products. All the products are tested in a lab and they all do what they say on the tin. It's very hard to prove that a product has failed once below ground. Contractor guarantees, the best type of guarantee because these warrant the installation and they usually come with a 10-year insurance-backed guarantee. Contractors will also take on the design under their own professional indemnity insurance. We can also arrange for bespoke insurance guarantees. These are 12-year latent defects guarantees issued by the underwriter direct to the client. These are available through our network of approved installers, where the design is undertaken by Newton and the installation is undertaken by our network of approved installers. There's usually a premium to pay with these, approximately 2.5% of the waterproofing cost. Newton Waterproofing are able to offer site visits and quality assurance reports using a special app to assist the installers, and we can tie these in with the gas verification companies. Newton Waterproofing work in partnership with our network of approved specialist waterproofing contractors who are at the pinnacle of what they do and can fulfill the role of waterproofing specialist as recommended by BS 8102/2022. We have them vetted technically and financially, and they must have a proven track record in waterproofing, including accreditations with the industry associations, CSSW qualified staff, highly trained and competent use of Newton waterproofing systems to be able to offer long-term installation guarantees and take on design liability through their own PI. With an ever-increasing focus on sustainability and environmental credentials, the construction industry in particular is coming under more and more pressure to improve and reduce its overall impact on the environment. The Newton Membrane Recycling Service is the only waterproofing recycling scheme in the UK, leading the way in making our industry more sustainable and more accountable. Newton have also achieved the BES 6001 Responsible Sourcing Accreditation. Thank you for listening. If you have any questions after this event or would like to contact us for project-specific design assistance, we would be glad to hear from you. And we have all these tools on offer to ensure you find the correct solution.
Good morning, everyone. I hope that you all enjoyed today's presentation. For anyone that's new with us this morning, my name is Carol Mikulak, and I am your host for this live Q&A session. So if you have any questions that you would like me to put to our panel of experts, please just ask away in the YouTube chat feed. Or you can alternatively send us a direct message to our Twitter page @Proctor Group, or you can drop us an email to webinar@proctorgroup.com. Now, as always, if there's anything in particular that you would like to discuss with us in more detail, please just get in touch by any of the usual means and leave some contact details, and we will certainly get back to you as soon as we are done. Now, if you have registered in advance for today, you will get a follow-up email from us. And in that email, you will get details on how you can request your own personalised CPD certificate. That email will also have a link in there so that you can watch back the full presentation and this Q&A session. So please pass that on to any of your colleagues or friends that you think might find this interesting. You can also watch back any of our own previous webinars from the past 2.5 years, and these can be accessed from our YouTube channel or from the online members area of our website. There's lots of topics covered on there, so please have a look and see if there's anything that's relevant to you. And please also, if you can, subscribe to our YouTube channel, where you will get updates on what we're involved in, as well as details on forthcoming webinar content. Do give us a thumbs up and leave some feedback as well. All feedback is read and it helps to shape the content for future webinars. Now, moving on to our next webinar, which is also now available for registration. This takes place 2 weeks' time on Friday the 28th of October at the usual time of 10 AM, where we will be covering pitched roofing design considerations. This presentation, it gives an overview of pitched roof design considerations and regulations in the UK and Ireland, along with discussing the type of construction membranes used in pitched roof underlays and the effect their performance has on design. It also discusses the implications of hygrothermal focused roof design on the overall building energy performance. This was one that we had planned to do a few weeks ago. However, due to the sad passing of Alan Proctor, it was postponed. So it's not a duplicate, if anyone does remember me mentioning this at the start of September, sorry. Right, without further ado, let's move on to our Q&A session, and I'll introduce you to our panel for today. First with me, we have Ian Fairrington, our Technical Director. Good morning, Ian.
Morning, Carol. Morning, everybody.
Next up, we have Matthew Spiller, who is our National Technical Sales Manager, covering ground gas protection. Good morning, Matt.
Morning, Carol. Good morning, everybody.
Good morning. And next up, we've got Paul Young, one of our in-house technical advisors. Good morning, Paul.
Morning, Carol. Morning, everyone.
And I am delighted to also introduce you to our very special guest for today, who gave us the fantastic presentation that we have just watched. Technical Director at Newton Waterproofing Systems, Richard Crossley. Good morning, Richard.
Thank you very much, Carol, and good morning to yourself and to everybody who listened to me today.
Fantastic. Now, I am really pleased to see that we've actually got some questions coming in both on email and on the YouTube feed. So as always, keep them coming in and bear with me as I am collating them in from different places. Right, it's only correct that we start with you, Richard, if that's okay. This question on YouTube from Greg Robertson, who asks, do I need to waterproof and gasproof a car park that is below ground?
Okay, that's a great question, Greg. It really goes back to that initial slide where we say, you know, what is the structure and what are we using it for? So we're using it for a car park. What is it made from? Probably now I'll assume we're going to go with concrete on this car park. So if this car park is, you know, we need to talk to the client. We need to find out, you know, is it one of those sort of like a station car park, a municipal car park, nap end of town, smelly stairways, for example. You know, we're going to accept some seepage in there, and you know, maybe designing that car park to a water tightness class of 0, so it's cost effective, is what the client's going to want. And within that car park, we can vent it. So again, we need to find out what's the characteristic situation in that car park as well. Are we in a really high gas state or are we in low? If it's a low CS value, in fact, anywhere up to where we meet 4.5 points, then we can just vent that car park naturally. So we're going to have seepage. It's going to be pretty damp. There might be rain coming in through louvers and things like that. And then we can vent it. It's nice and airy, so we're not going to have any gas buildup. Maybe this car park is under £100 million build mansion, and this car park is in a really high gas area. The client's not going to want any seepage. It's going to be a completely dry internal environment. And if we've got high gas, we might need more than the 4.5 points to get the ventilation. Ventilation might be quite difficult. It's very closed underneath the house. So then we're going to have to look at higher tightness classification, so tightness class 1, so BSE in 1992, that's 0.2 millimeter crack width. We need to talk to the engineer, design more steel in, so we've got 2.5 points then from this structure, and then we can get extra points from membranes, and we can look at then how we can keep it dry. So we might need to use type C systems, partially or wholly, which we could also then use for ventilation, for depressurization to get extra points. So to answer your question, it's quite vague, but we need to know, where the project is, what is the gas, what is the characteristic situation, and also, what are the client's expectations for that car park.
Perfect, thank you so much. Richard, if I could just stick with you, John Sparks has just asked on YouTube as well, would you insist that Appendix B of BR211 is 100% completed to allocate contractual responsibility? That one you can comment on.
Thank you, John. Thanks for listening as well. And good question, testing my knowledge of the BRE here. Appendix B is, for those who don't know, it's a checklist, like a quality assurance checklist. And with the question, sorry, is does it have to be 100% completed? For basement waterproofing, that's quite difficult. So I think the checklist really, if I remember it, is mostly for damp proofing membranes at ground level, and it includes, sort of like I said at the beginning of my presentation, with gas proofing above ground, you're depressurizing, you're ventilating, you're creating that ventilation. Prop to have some great products for this, and then you're creating a barrier. So the checklist is really good for that, and it's very important that professional bodies such as yourselves, John, get involved with that verification and get that done properly. In a basement situation, it's still very important, but it's not quite there, this checklist, and it needs further work, maybe a separate checklist or something. But yeah, very important that it's done. Who it's allocated to take that liability, I don't know. I think the companies, part of the British Verification Council, those sorts of companies need to be involved and work with people that are specialist approved contractors, so they can all work together to get the best result. I think really to keep the underwriters happy, if we allocate it to the underwriters. Hopefully that answered that.
Thanks, Richard. Okay, Paul, let's move on to you, sticking with some YouTube questions here. This one from Marina, who said, can gas membranes be used to provide protection against water?
Yeah, that's a good question, because obviously there are some membranes that do both. Like, some of the waterproofing membranes offered by Newton are also radon barriers. But in general, if we're talking standard kind of loose laid gas membranes that you would put below a ground floor slab, we would say no. They're not designed to protect against the hydrostatic pressures that are often acted on from water in the ground, particularly with a high water table. So we would say the gas membranes loose laid would be considered damp proof, but not waterproof. They're actually two quite different things. Yeah, the short answer would be not exactly, no.
Okay, perfect. Thanks, Paul. Matt, let me come to you with this next one. Staying on YouTube from Simon. Can I just treat the waterproofing and gas protection as two separate installations?
Good question, not uncommon. I'd like to know a little more about that specific project, but in general, I would say that the general rule of thumb is that the two challenges must be tackled with at least a joined up approach. For example, if the grain gas was dealt with separately, you could end up with just a loose laid gas membrane installed vertically and horizontally, which then could be compromised by the hydrostatic pressure that Paul just alluded to. So no, it should definitely be a joined up approach.
Perfect. Thanks, Matt. Okay, Ian, let's not forget about you. Let's come to you with this next one, sticking with YouTube, from Danielle Simpson. If I have a waterproofing project that also needs gas protection measures, who should I contact? A gas specialist or a waterproofing specialist?
Yep. Continuing the theme, it's another question. Looking at my screen here, I've got Matt on my left and Richard on my right. So I don't want to cause any offence here. I think just the same thing as Matt said there, a joined up approach is necessary. Waterproofing designers have become a lot more au fait with gas membranes, and hence the relationship Proctors have with Newtons that have that joined up approach that Matt mentioned earlier. You've seen how complicated the waterproofing side of things can be. Richard's given us a great presentation there. So I think you'd be foolhardy not to look at a waterproofing specialist for that. Obviously, we would recommend Newtons for that. That keeps me in the good books with Richard there. But yeah, you would need a waterproofing specialist there with some help from Proctors, hopefully.
Correct answer, Ian. Okay, before I jump on to some emails here, can I just come back to you with one more, Richard? Another question from Marina on YouTube. What if I'm using a modular form of construction? Presumably looking for a bit of help with that one.
Yeah, another good question. And we see a lot of use of modular forms of construction. One of the issues with modular forms of construction is that they can be quite porous. There's a lot of paths within them for water to find a way through. And with modular forms of construction, even if you infill them with a concrete, there's still a lot of paths through. Hollow blocks and insulated concrete forms have lots and lots of ties holding them together. So even if you use concrete, the water will just get around the concrete and come through. So with those forms of construction, we cannot allocate points for gas for the table 5. So we have to then rely on table 7, so external membranes, and then possibility of maybe removing the internal form and using an internal membrane. But if we're using A and A, we've got to think that the properties have to be different, so that if any defects, if we use a rend on the outside and a rend on the inside, both renders could crack, defects could align, and water could come in. So we've got to think about differential systems. A, to get rid of or to keep the water out or manage the water, and then B, to deal with the gas. So if we're going to, they'll be built already, so we're going to have to post-apply a membrane on the outside. So it's usually going to be a liquid membrane. That liquid membrane has to meet table or section 8, table 3 of BS 8102 2022, and it has to meet table 7 of BS 845 in order that it will work as waterproofing and gas proofing, and then similarly internally. So the difficulty really with modular is we've lost the structure, and we're relying on A and C systems then to do waterproofing and gas.
Excellent, thank you, Richard. Okay, let me go to some of the emails that have come in. Matt, can I come to you with this one? This is coming from Paul, who has asked, which British standard do I refer to on a structure below ground that has methane present? Would it be BS 8102 or BS 8485? You're still on mute. Sorry, Matt.
Sorry, guys. Richard's presentation covered this one off. I thought the answer is both. The 8102 you would apply to the waterproofing aspects, and the 8485 standard to the gas protection. And it's really not always simple to marry the two standards together depending on your structure. Because when it's just grain gas and we're just looking at BS 8485, we tend to rely heavily on ventilation below the structure. And as Richard said, trying to ventilate beneath a below ground structure, that void often fills with water and then doesn't provide any ventilation at all. So the answer is both standards need to be applied.
Perfect, thank you very much. Ian, let me come to you with this one. It's another one here that I think you can help with, from Philip on email. BS 8485 states that a methane membrane must have a minimum weight of 370 grams per square metre and a thickness of 0.4 millimetres to comply. Why is that?
Why is that? When it went to public consultation, I asked that very same question of the committee. Unfortunately, we weren't on the committee, but we had a chance to comment on it in public comment. I think the idea behind it is to try and improve the gas membrane standard. So it was a good idea to put some parameters in there of weight and thickness. I think the problem I had was I don't think weight and thickness is a parameter for robustness necessarily. I think tear resistance, tensile strength was much more important, and that should be the main drivers. But I do like the concept of trying to improve the standard of gas membranes in the industry, and obviously Proctors would support that and make people strive, rather than go for cheap commodity products, to raise the standard of membranes.
Perfect, thank you, Ian. Richard, let me come back to you with this one. Another email here. We've had quite a few emails come in, which is great. This is from Jeff. Do you think that the recent update of BS 8102 makes designing a combined waterproofing and gas-resistant solution easier?
I think the new release of the 2022 release of the BS 8102 makes it much clearer about the structure. So the 2009 edition was quite vague with the structure, with type B and crack widths. Actually, if you go back to 1973 and also 1990 versions, they said the same thing as this current version says. You know, it's all about crack width. Obviously, they used different British standards then. It was a BS 8007 and 8110, which is a general concrete. But they were very clear on crack widths. 2009 got a bit wishy-washy. The new 2022 version is really clear on these crack widths. So when you're thinking about, you know, how do I keep water and gas out, and you're thinking about those points in table 5, I think the new British standard makes it much clearer. Also, you know, we're talking about 0.3 and 0.4 mil membranes, and we do see a lot of polyethylene membranes used below ground. Section 8 now of the new British standard makes it much clearer again about, you know, requiring a full bond. So if you can get a dual purpose membrane which keeps water and gas out, and then, you know, and it's compliant to new section 8 in BS 8102 2022 and BS 8485, then you can correlate them. So there's still some gaps in there, but if you use specialist gas designers such as the likes of Procter, and you use a specialist CSSW waterproofing, they can pull the right bits out of the codes and correlate them.
Excellent, thank you. Richard, can I stay with you with this one? This has come in on YouTube. It might be one you might need a bit more information from Edward, who I noticed is in Saudi Arabia. Welcome. Edward asks, what is the best waterproofing system of my AHU area, which I understand is air handling unit, which is directly above the security scanning area of my airport project?
Okay. Yeah, so you've got probably a grade 3 environment. So that's grade 2, where no seepage, no dampness, but then you probably need extra ventilation. The best system, it's very hard to say one system fits all. So really, you know, it's what is the structure, and you know, what are the gases? What is a CS value there? What kind of gases are we resisting? Or is it ground contamination? You know, it's not all about gases. Sometimes you need to think, you know, do I want a product which is going to hold back, you know, diesels or hydrocarbons or something like that. So I can't answer it exactly, but I would say that the best system is the one which correlates your structure with the place the structure is in, and the characteristic situation of the soil, and then also keeping the client happy. The client's expectations for the air handling unit is going to be completely dry, you know, and so you're going to probably need dual systems in there, combined dual systems.
Excellent, thank you so much. That's it, not one size fits all, does it?
No, unfortunately, no.
Perfect, right, Paul, let me come back to you with this one. This is an email from Ewan. Is there a higher risk of radon or other ground gases entering basements than a typical ground floor assembly?
Yeah, absolutely. I mean, you have a lot more, when you're talking basement, you have a lot more surface area in direct contact with the ground. So any gases that are kind of present in the area, they have more access to kind of permeate into the building. Also, as well, if you consider when you are just building above the ground at ground level, you have the opportunity to put you know, ventilation systems in, like the Pro Void system. which helps to dilute the gases, prevents them from collecting underneath the floor and eventually seeping in through the slab. It's a lot more difficult to get a good ventilation system on the outside of a basement that allows that gas to travel elsewhere. So I think it's especially important that you have a continuous water and gas-proof barrier around that basement structure.
Perfect. Thanks, Paul. Richard, another one. You're a popular man this morning, of course. Let's come back to you. This one's coming to us on Twitter from Abigail. If the BRE 211 and the BS 8485 allow a 0.4 mil polyethylene DPM, why can't I just use this for waterproofing?
Yeah, it's a good question, and we do see it used a lot actually. A 0.4 mil DPM, if you put it underneath a head of water pressure in a lab, it will resist that water. So you will hold water back. You go and get a bit of polythene, tip some water on it, it runs off. It's waterproof. But if you put it around your basement, what we've got to think about is how easy it's folded, how easily it's lapped and sealed, and how much reliance are we putting on those seals on a Monday morning in a muddy trench, in the drizzle. Maybe the operator's not feeling too good on a Monday morning. How perfect are those laps going to be? So the waterproofing, the tanking materials we use for compliance to the BS 8102, they're designed to factor in these defects. So they can be loose laid, so they can be applied over a void former board. And then when the concrete's cast, it actually forms a full bond with the tanking membranes. Many of them are, especially if they're gas or dual gas and waterproofing membranes, many of them will incorporate a 0.4 mil polyethylene, but they will also have other features to them. So they might have hydrophilic elements, bentonites and hydrophilic polymers. They might have just a much more rigid construction. They might be more flexible, but importantly, they form a full bond with the structure, with the concrete. So we can use these loose laid pre-applied membranes over a void former board. The concrete's cast to them. If the ground then heaves and falls away, as we see in an example I showed in my slides, was a suspended slab with the concrete piles. If the ground heaves and falls away, a polythene membrane will just fall away with that ground, whereas a bona fide tanking membrane will be stuck tight to the underside of that slab. So it's really about forming that full bond with the structure, but also trying to achieve this homogeneous tank, whereby laps, for instance, would self-seal. Any fixings, any holes might self-seal as well. Self-sealing for water, not so much for gas, because the gas elements of those might be punctured. So, stick to the Section 8 requirements for waterproofing.
Yeah, perfect. Thank you. I just noticed Edward had commented back. I think he's going to get in touch with us with these details, and we'll put them straight on to you, Richard. I really appreciate keeping in touch. My project is ongoing, and the issue on waterproofing the AHU area is very critical as airports operate 24/7. Absolutely, we cannot compromise security. So yeah, if anybody does have anything that they want us to put directly to Richard, please just get in touch and we will pass your details on, and he will certainly go into more detail with you. Ian, if I can come back to you with this next one, a message on Twitter from Steve, who has asked, do waterproofing and gas protection measures need third-party certification to be compliant with UK regulations?
Third-party certification, that's a great question for me to answer, I think. I was actually at a panel discussion just last week at the UKCW with BBA and others to discuss this very point. And the point was made actually from the audience, do you need third-party certification to comply with the regulations? So very similar question to the one that's asked this morning. Effectively, theoretically, no, you don't. And the regulations don't necessarily stipulate that you need third-party certification. Some British standards do, that may be referenced in the regulations. But BBA, for example, in third-party certification, do have a purpose in showing fitness for purpose, especially for new products as well that are new to the industry. So third-party certification can help comply with the building regulations, even if it's not written that you need it. So certainly building control, NHBC like to see BBA certificates. And as a consequence of that, the Proctor Group do have a number of BBA certificates that helps give comfort to the specifier, building control and NHBC, and especially in the gas membranes that we're talking about this morning, we do have a number of BBA certificates to give people that assurance.
Perfect, thanks Ian. Richard, let me come back to you. Another direct question that's come in for you here from Ed on email. What's the difference between a PCA qualified waterproofing contractor and a local tradesman?
Yeah, that's a good question. So the PCA, for those who don't know, is the Property Care Association, but they actually have within them a structural waterproofing group, amongst other groups as well. So they hold a lot of the specialists. It's the PCA really who instigated the CSSW qualification, which is completely independent by ABBY, awarding body, but they are sort of trying to drive the industry, trying to drive skills. So a PCA approved contractor will have a lot of the necessary requirements. They are technically and financially vetted. So they're they've got the thumbs up approval from an industry sort of association, and that's for waterproofing. PCA do get a little bit involved with gas, but also there are the British Verification Council would also have approved verifiers. Really important that they tie in with the PCA approved contractors so you get the installation and the verification side all tied in together, and using the manufacturers as well, making sure the manufacturers are affiliated with these associations, I think is quite important. Make sure that everyone's singing off the same hymn sheet. The PCA contractors, they all CSSW. Most of them are waterproofing design specialists, so that's the highest accolade you can get in waterproofing. And many of them also are gas specialists as well. So you get a good sort of cross section of knowledge within the PCA specialists. A general builder might have all those skills, but you're taking more of a risk because you don't know where nobody's sort of put the thumbs up on them, or given them that tick of approval.
Yeah, not something you can just take a gamble on, is it, when you're talking about things like that? Perfect. Okay, Paul, let me come back to you if I can. An email here from Thomas. What measures should be used to protect from moisture or gas in floors above the ground where there is no basement below?
Okay, yeah, I mean, I guess I kind of touched on that a little bit with one of my previous questions, in the use of a loose laid ground gas membrane. As I mentioned, they also act as a damp proof membrane. Now, you don't have the issue with hydrostatic pressure in the same way that you do with basements, so that's why you can use those, and it doesn't have to be a fully bonded system. So generally what you would do is, like was mentioned in the presentation, is following the points scores requirements that are given in BS 8485. So depending on how high the risk is on the site, what point score you need to achieve, you can combine a loose laid gas membrane with a ventilation system. Also the type of ground slab you're using as well will come into effect. So I mean that's something that we can kind of help people design, but generally it is incorporating a damp proof gas membrane, and also as well looking at the wall assembly, whether you need to kind of take that membrane through the cavity if there is a cavity. All these kind of details are quite critical. So it's usually a good idea to get someone like us to just review it and make sure that it's all designed the right way. Also, just to mention as well, is you might have a structure where there is actually a basement under part of the building, but the rest of it, maybe an extension or something like that, there's no basement. So you've actually got a combination there. You kind of need to make sure that remains, continuous as well. So you've got that damp-proof barrier leading into the waterproofing. So what we can do is work with Newtons. They can help us with the basement design and the waterproofing there, and we can come up with some details that we can kind of lap the membranes in together, because they are all compatible with each other. Make sure that you get that proper seal.
Right, thanks, Paul. Okay, I actually only have another couple of emails that have come in here. So if anybody still would like to ask anything, please just quickly drop it into the YouTube chat feed, or as always, we can get back to you later. Let me come to you, Matt, if I can, with this one. This is an email from Jerry, who has asked, does the water and gas proofing installation need to be verified by a third party?
Yes. Anywhere there are gas protection measures installed, they should be independently verified in line with Series C735. It's very important that it's independently verified. We don't want the person that's installed marking their own homework, essentially. I would strongly suggest on a combined system that, especially, that you get the verifier on board early pre-project, because they may need to make multiple site visits to test and sign off at different stages, and this can be much more easily organised if all parties are fully aware of the phasing and the timings of the installation. So yes, it's a must.
Perfect. Thanks, Matt. Okay, one last question, Richard, if I can just bring this one to you. Benjamin has asked on email, what kind of guarantee should I expect on a waterproofing project if I use a qualified professional design and install company?
Yeah, that's a really good question. So there's a number of guarantees available. And what we would say is, make sure that the designer of the waterproofing has appropriate levels of professional indemnity insurance. That might be the architect. The architect might want to cover that, or then the architect might want to use a certificated surveyor, instructor waterproofing specialist who has that PI and can take that PI on. Once the design is undertaken, if it's for water and gas, then as Matt was saying earlier, involve someone who can verify that design for gas for CO735, which might be really tricky because you might not know, the future of the project. You might not know how the ground worker, who hasn't got a tender yet, is going to actually undertake their temporary work. So some of the sequencing might be quite difficult. So it's important to get everyone in that project design team: engineers, architects, gas verification specialists, heritage officers, insurers as well. Get the local officer for if it's local authority building control. Get them all involved, and that's the important start. Once you've done that, then you can use approved contractors. The approved contractors often also have PI, so they can then take over the PI because they're agreeing to the design, but they come on board at tender stage. You want to make sure that the approved contractors have got at least an insurance-backed guarantee. So one of the reasons they get financially vetted is that make sure they don't go bust. If they do go bust, that's when the insurance-backed guarantee comes in. It's like a double trigger guarantee. Unfortunately, you can only get that for 10 years. Insurance underwriters are really tight at the moment. They want to make sure it's a good, safe design as well. So we can go a step further than that. And if we use our designs, if we use our approved contractors, we have an underwriter, A-rated underwriter out of Lloyd's, who will actually give up to a 12-year latent defect insurance policy. And that misses all of us parties out, goes direct to the client. There's a premium to pay on this though, usually about 2.5% of the waterproofing cost. So really, it's all about cost versus risk. Is it that damp car park? What kind of warranties do you want? Product warranty, is that okay? Not really worth the paper it's written on, but BBA cert with a product warranty, or do you want an installation guarantee, or do you want a full latent defects guarantee? It all depends on what the cost versus risk decision is, and if you want a full latent defects insurance policy, it's going to have multiple systems in there because the insurers won't cover it otherwise. They're going to want to see a good structure and with a Type C system where the consequences of failure are unacceptable.
Excellent. Thank you so much, Richard. Okay, I think that's covered everything today. Thank you to those who've left feedback already on the YouTube feed. It's great that we're covering people. It's great that we're getting people from all over the world joining in with us. It's fantastic. If there is still something you would like to ask us, or like I said before, if you do want us to put you in touch with Richard directly, just send in your details and we will certainly pass them on and someone will get back to you straight away. Please subscribe to our YouTube channel, give us a thumbs up as well as leave feedback, and do register for our next webinar taking place 2 weeks today, Friday the 28th of October, where we will be covering pitched roofing design considerations. So from all of us here on screen and everyone behind the scenes, we'd just like to thank you, as always, for taking the time out of your busy day to join us. And of course, very special thanks to Richard for sharing his presentation earlier and for joining us on the panel this morning. So do enjoy the rest of your Friday. We do hope to see you back here in 2 weeks' time. Take care, everyone, and goodbye. Thanks.
Bye all.